I'm Josephine. I'm a first-year student at MIT and I'm studying computer science.
Nice to meet you. So, the first question is, most unknown or interesting neurological diseases that you know?
I personally think that the most interesting neurological disease is Alzheimer's disease. Those two things in the brain can cause memory loss, and it affects many old people, and so it has affected people in my family before. And I find it to be a really devastating disease because you live like a whole life, and then suddenly as you grow older you should be able to be happy with your memories, and then you lose your memories. There is a really interesting study called the nun study, and it looks at different nuns. So some of them are able to read and they're literate, and then other ones aren't able to. And so both of them have the markers of Alzheimer's disease in their head, except the literate nuns, the ones that are able to read, they have less, or they show less cognitive decline. And it shows that like certain things that you do throughout your life, like reading or doing puzzles or anything that requires like exercising the brain or creating new connections in the brain, that can be a prevention for Alzheimer's disease. And sleep is also a prevention for Alzheimer's disease. And so there are many ways that we can like prevent this memory loss.
Is there a concept of night and morning people, or it's just a stereotype?
So studies have shown that there is actually a difference between night and morning people. So people have something called a circadian rhythm, which is just like your internal clock, and it's usually affected by things like the light or things by environment. So like when I came from America to Kazakhstan, I had jet lag. Nighttime here is the daytime in America, but because my circadian rhythm was able to adjust to the daylight, so now I don't have jet lag anymore, but I will when I go back. People who identify as morning people and they're like more alert in the morning, their circadian rhythm is adjusted so that the time when they're sleepy is shorter and also earlier in the day. And so at around like 9 a.m. then they start feeling alert. And so that's why morning people are able to like wake up earlier and be more alert in the morning.
Can you tell us how do white and gray matter interact?
Yes, so white and gray matter are found in the brain. Gray matter is the body of the neuron. So like the neuron where all the entire cell is, and it has like dendrites and it has an axon. And the axon is what makes up the white matter. If you think about it, the neuron or the gray matter is kind of like the destination, and the axons are like the roads. And so the white matter transmits, it has all the nerves and the connections, and it transmits information from neuron to neuron in the brain.
Do you have any interesting facts about children behavior development?
So the human brain undergoes significant development during childhood, and they have peak synaptic density from ages 2 to 3. So what that means is that you have the most connections in your brain. And there's something called synaptic pruning, where the connections that you use really often, those are strengthened, and the ones that you don't use, those are weakened and they eventually disappear. And so that is to make sure that your brain is focused on more like important topics. But if you're like, when you're a child, if you don't learn important skills like logic or creativity or things like that, then you might lose those skills because of synaptic pruning. So it's important that children, while their brains are still developing, that they're like constantly enriched, or their brains are stimulated with activity. And so children, they also learn a lot from the people around them, so like their parents or people who are taking care of them. And so they imitate behavior, and that's also very important because when children grow older, they will act like the same way that their parents have taught them to act.
What fascinates you about neuroscience?
So I think it's really incredible what the human brain is capable of. And actually some research that I'm currently doing at college is a psychology study on kids. And so there's a pattern learning task that we've given to adults before, and it's like you're shown the first few iterations of a pattern, and then the adults have to predict what the rest of the pattern looks like. And so the adults are really good at predicting. We have a lot of AI technology, and neural networks, they're very capable of predicting these patterns as well. However, they require a lot of data sets, like thousands of data sets, in order to train them and so that they become proficient. However, humans, they only have to look at the sequence once in order to kind of get an idea of what the rest of the sequence will look like. And adults are typically better because they have more experience throughout their life in recognizing patterns. However, children are also surprisingly good at recognizing these patterns, even though they haven't had that much life experience yet. And so like I give tests to children who are ages 4 to 6, and they're able to complete the task at a similar level of like maybe a neural network that has had hundreds of patterns shown to them.
How do hormonal changes during adolescence contribute to differences in teenage behavior?
Yeah, so teenagers, they are known for like being more risk takers and having or prioritizing social relationships, and so that is like backed by neuroscience. So when you're an adolescent, your prefrontal cortex, which is an important part of decision making and logical reasoning, is still developing, and so that's why teenagers, they're more prone to making impulsive decisions, and they take risks more often. When children become adolescents, they transition from taking or I guess being inspired by adults or being inspired by their parents to being inspired by peers. And so you'll see that adolescents, whoever they spend a lot of time with, they start acting like them, and that's like their social connection. So they start relating to people who are of similar age to them.
What are the current frontiers in neuroscience research, and what breakthroughs are anticipated in the near future?
Yes, so I think currently a lot of rising technology in neuroscience is like neuroimaging. So we have MRI technology and like technology that allows us to look at the brain and changes in the brain. And so that technology is getting a lot stronger. And so we're able to learn more about how the brain works, or being able to detect diseases early on. And so like, for example, in Alzheimer's disease, you can kind of use neuroimaging to figure out when someone has Alzheimer's disease, but you can't figure out fully until the person actually dies and you have like a biopsy of the brain. And so I think stronger neuroimaging technologies, they can be able to predict neurodegenerative diseases or neurological diseases more early on, which is great for prevention or for like figuring out how to treat it earlier on. And there's also a technology that's like the brain and machine interface, which is connecting your thoughts or connecting the brain to a machine or computer. And so actually like Elon Musk has been working on technology called Neuralink, and it's supposed to be able to connect your brain to a computer. And so that can be really helpful for patients who have paralysis, so they're unable to move and they can communicate through the computer, or people who are like amputees and they need to use prosthetics. So disabled people, if they're able to control a prosthetic with just their brain, then that is like basically a great replacement for their arm or their some kind of limb that they've lost.
So, Josie, what is your plans for your future career?
I wanted to learn like a little bit about AI and see its applications for the future. So it's like a very new technology right now, and it's become really popular in the last year. And actually, AI has been on an ongoing research for decades now, but because previously computers weren't powerful enough to be able to run these softwares, so they would like take days to run an AI software, and that's not very practical because you can't spend days doing something. And so now when like computers are much better, they're able to run AI and it's become a lot more popular. And so I think like that's something I might want to do in the future. I might also want to see like applications of computer science in biotech, or just like related some kind of interrelationship between computer science and biology.
We wish you luck in the future plans, and
you.
thank you for the interview. Is there anything you want to share with our listeners?
Good luck for the future. Don't give up. High school is a very stressful time, but everything works out in the end.
Thank you very much. Thank you.